Good morning, class. This will be new course for this semester, BWS21403 non-relational and NoSQL database. We already learned about relational database with query language SQL last semester. So that subject will be prerequisite for this subject. So this subject will be kind of extension from SQL. Okay, but this one we will learn more on NoSQL type of queries. Still we will learn about some queries, but this query is more on NoSQL query. Okay, so chapter 1, let's go through first chapter 1, introduction to non-relational database. So these are the contents. It's going to be very small chapter. Okay, so these are the learning outcomes, so you will be able to understand at the end of the course fundamental of non-relational database, the need for non-relational database, compare and contrast the relational and non-relational databases. Okay, let's do a small recap about database that we have learned last semester. A relational database is a type of database that organizes data into rows and columns, which collectively form a table where the data points are related to each other. So it's like a table form data. Data is structured across multiple tables, and databases organize information into related tables. Okay, and why we call this as a relational database, because each table in the database will be connected to each other, each one table. Okay, any table in the database, for example, they are connected through primary key and foreign key. Okay, so data model visualize this relationship, and this model provide a visual representation of how tables are connected. And we know that we have learned about entity relationship diagram, right? So SQL queries combines and summarize the data, where we learn about DML, DDL, TCL. Okay, I hope you remember or recall back at least a little bit. Okay, SQL is a structured query language. DDL is a data definition language to create table. DML is manipulation language. TCL is a TCL is a transaction control language, and DCL is a data control language. So these are the four things, but mainly we focused on DDL and DML last time. The tables can be joined using common fields like customer ID. This allows for the combination of related data from different tables like primary keys. So combined data enables valuable reports. So this report can reveal the trends, patterns, and insight for business decisions. Okay, the data that in the table form, it's already in the structured format, right? So we can query and we can get some report from the available data. For example, the customer and the transaction table. So from these tables can be joined to analyze customers' purchasing behavior across different industry. So each customer, they make a transaction. So every single transaction belongs to definitely one customer or more customers. So from this transaction, we can analyze the purchasing behavior of the customers, where it can helpful for future decision making for certain organizations. So this is what we call as database. Generally, database is a place where we store the data. Okay, just remember that. Okay, let's back to non-relational database. What does non-relational mean? Okay, a non-relational database is a database that does not adhere to the tabular schema, rows and columns with fixed data types and relationship. So there is no tabular form, there's no table in this non-relational database that characterizes traditional relational database. So compared to relational database, non-relational database, there is no table form, because they are mostly work with unstructured data or semi-structured data. Okay, but remember, when we go to database, relational database, they are more working on structured data. Okay, because they already have a table form. But for non-relational, we don't have a table form there. So the key idea, instead of relying on rigid schemas and structured query language SQL, for all operations. Non-relational database offer flexible data model. They are quite flexible. So you can modify anything, you can do anything that you want. So they are quite flexible. So this is one of the key criteria or key property of non-relational database. Think of it in this way. For example, imagine you want to organize your book, and a relational database is like meticulously cataloged library with strict categories and ISBN. So they have like a categories, they have certain categories, and they have a ISBN to identify the books, for example. But when you go for non-relational database, you don't have to organize these like how we organize in a relational database. Okay, but this will be your like personal collection. For example, you might group the books by genre, author, even just file them based on your what you're reading now, based on for the purpose that you're reading the book. So it can be from anything that you want to modify according to your own preferences. So that's why I say it's quite flexible model when it's come to non-relational database. Okay, there are actually 4 major characteristics of non-relational databases. The first one is schema-less structure, flexible. Okay, unlike relational database that required a predefined schema, like we have to define the table, the columns, right? Okay, I hope you remember attributes and entity. Entity is a table, attribute is a column. Relationship. Non-relational databases are schema-less or have a dynamic schema. Generally, it will be in XML format or JSON format. We'll see that later on. So the benefit of this particular characteristics, these allow flexibility, enabling application to store varied and evolving data without altering the database schema. So generally, we won't alter the overall database schema. We can just fit anything, any data that we want into the database directly without affecting the overall database schema. Okay, you can see here. Example, in a relational database, storing product details required a fixed structure with predefined fields such as product ID, name, price, and category. In a NoSQL document store, for example in MongoDB, different products can have a different attributes. For example, product ID, name, brand, and price. Okay, the first one. The second line, you can see product ID, name, brand, name, brand, and also the price together with color. So here the second document has an extra field called color. I highlighted as a yellow color there, which would require schema modification in relational database, but it's easily handled in NoSQL. But when it's come to SQL, when you want to modify or you want to add one particular column in a table, I won't say that it's very difficult, but it will consider you have to adjust, alter the table. You create one new column, you create a new attributes. After that, you key in the values or fill up the values for the data in the table. So in NoSQL format, you don't have to worry about that. So you can directly modify without any issue like in SQL format. Okay, number 2. Second characteristic, distributed architecture, scalability and performance. Definition, NoSQL databases use a distributed architecture, meaning data is stored across multiple servers, okay, rather than a single centralized database. Generally, we learn, right? We learn about multiple database, centralized, multi-user database, centralized database, distributed database, right, during relational database time. But for this case, they already mentioned here. You can see, let me get the pen. Okay, distributed architecture, meaning that the data is stored in multiple servers. One reason why they are stored in a multiple server, actually there is one advantage. Okay, when you when you store the data in a multiple servers, let's say one server got issue, you still can get the data from the second server. So this is the use of multiple server when it's come to NoSQL. Okay, so why it matters? This allow horizontal scaling. We will see that what is horizontal scaling and also vertical scaling, where more server can be added to distribute the workload as the data grows. Okay, because this NoSQL is actually working with big data, and you know the meaning of big data, right? The volume of data is too large. It's very huge. Okay, huge enough where we can't deal with the normal SQL, so that they come out with a solution, new solution called NoSQL. Okay, so example here, relational database, they are more on vertical scaling. NoSQL database, they will be more on horizontal scaling to handle, okay, you can see vertical scaling, handle more data, upgrade the server, okay, distribute the data across multiple server, adding nodes in the cluster. Okay, we just need to add the nodes in the cluster when it's come to big data here. Okay, that is an example there. So third characteristic, high availability and fault tolerance. Definition, okay. NoSQL databases are designed for high availability, meaning they remain operational even if some server fail. This is what I mentioned just now. If any of the server is failed, they still in operation because they have multiple servers connected. Okay. Key mechanism of these multiple servers are replications. When replication means they can copy the data automatically across multiple servers. Partitioning means, like, you know, large data sets are split into small part of the data set. Partitioning means division. Okay, they split the data into smaller parts and store across different servers. Example, Apache Cassandra is used by Facebook, replicates data across multiple data centers, ensuring user can always access their messages even if a server is failed, because they are already connected to multiple servers. So if server 1 is not working, server 2 is still working. Server 2 is not working, server 10 is working. So they still can collect the data. They can see the messages from another server. Behind the screen, we don't know that why the server is failed or whatever. But we still can connect and get the information that we want. So that is the best part of, you know, having this kind of multiple servers with, you know, non-relational database. And the last characteristic is optimized for specific use cases. Unlike relational database, which follow general purpose model, NoSQL database are optimized for specific data model. Okay, we have a specific data model. Like for example, there are 4. Okay, key value store, document store, column family store, and graph database. We will see this in detail in coming chapters. Okay, so these are the 4 types of data models available. Okay, for example, you can see there the real life example. Twitter users Redis, the key value store. Redis is come from here. See, okay, Redis to cache trending hashtag and user tweet for quick retrieval. See, quick retrieval. Okay, so we will learn about what is key value, what is document store, what is column, what is graph base, okay, in coming chapters. So no worries about it. You just need to know there are 4 types of data models available. Okay, these are some examples of, you know, the data models that we have. I guess we will be using MongoDB for our practical. Hopefully it's working. Hopefully we can learn together lah. Okay, so you guys can go through all these examples yourself. I don't want to touch. Okay, this is a review question, so I want you to try the review question after go through this video. Okay, so every section I just simply prepare, like, you know, very simple review question to test your understanding. Okay, just go through and try to, at least attempt to do it. Okay, second, 1.2, why use the non-relational database? Why should we use non-relational database since we already have a relational database? We already learned relational database, right? SQL. But why should we still go with non-relational? One main reason is, as I told you, the data. The growth of data is big data already. So it's no more like, normal growth. It's like, huge growth of data, which is can't handle by normal relational database. So we need big data database. Okay, while relational databases are powerful and well established, they can face challenges in certain scenarios. Scalability for massive data. Can you see here? This is what I mentioned, huge data. Okay, handling unstructured or semi-structured data. Why we need non-relational database? Because to handle unstructured and semi-structured data. Relational databases are optimized for structured data. Relational, last semester we learned about relational database. Okay, RDBMS. It's more to structured data, but this non-relational database is more focused on unstructured and semi-structured data. So the agile development, frequent schema changes in relational database can be time consuming. Actually, if you learn advanced database, relational database, advanced normal database, you will learn about, how to improve or increase the performance of a database. You have to tune the database. Okay, how you can control the transaction, how you can pause a transaction and then continue your transaction. I still remember that I have given one example talking about when one joint account, two person want to withdraw from two different places or two different ATM. Okay, for example, you and your partner want to withdraw money and with the same account, okay, account A. Okay, when you want to withdraw account A and account B, account A need to wait for account B. If account B start to withdraw first, here the timing also will be calculated. Okay, so if this issue is not solved, there will be update issues on the statements. For example, if B is withdraw and A also withdraw, we don't know how much balance is there. Okay, if B is withdraw, if the transaction, sometimes the transaction is paused, okay, stop for a while, then we'll activate back after B finish the transaction. Okay, so that is advanced level about database lah, so you don't have to worry about it. Okay, so this is how we need to improve. In order to improve the performance, we have to use, we come out with a solution called non-relational database. So you can see here we have a vertical and horizontal database. So you can see here, okay, vertical and horizontal. Okay, the strength of non-relational database, which means the advantages. So we can work with the scalability and high availability, cost effective. Okay, it will be more cost effective than expensive vertical scaling relational database server. So their server is more expensive and the space is very big, not like because it's dealing with multiple servers, even though it's dealing with multiple servers, but the space, we have space more than enough, and I would say that it is more safer than relational database as well. It's flexible. Okay, the performance, it's flexible. The performance for specific data models, we have 4 data models, right? So it can give you significant performance in order to improve the retrieval of data. Remember, retrieval means you try to obtain the data from the database, and handling diverse of data. So we try to manage unstructured and semi-structured data, as well as structured data also can be managed through a relational database. So these are the strength of non-relational database that you should know. Okay, next, common use cases. So as I told you, it's about big data, it's dealing with big data, real-time data. Okay, real-time data means the data that comes with, time frame. Okay, content management system. Okay, when you have a system, you want to manage the system, so you can use a non-relational database, recommendation engines like, online retailers. Okay, social medias, you can use this. Mobile and application web. cache. Okay, caching is actually in-memory key value store for improving application performance. We try to retrieve more faster informations. The information more faster compared to when they stored in a secondary storage. Generally, cache memory, if you learn about hardware, about computers, okay, there's one cache memory. Usually we will have like L1, L2, level 1, level 2, level 3 cache memories. So where the data is considered a primary storage, where the data is stored, the data location is stored there in cache memories, where when you request something, it can act more faster to retrieve the data compared to the secondary. Secondary storage is actually the storage where we store the data in hard disk, for example. Okay, hard disk or an external hard disk or something. Okay. Okay, there's a review question again. So I want you to try attempt this question, try to understand, just to test your understanding about subtopic 1.2. And we'll continue with the next subtopic and the last subtopic. So we need to know what is the difference between relational and non-relational database. Obviously, we learn about SQL. So I told you that it's a structured, but when it's come to non-SQL, it's obviously unstructured or semi-structured. Scalability, one is vertical for SQL. NoSQL is horizontal. Performance, complex queries can be slow, but you can improve this. But it takes time because you need to learn about hash index. There are so many indexing that you need to learn. Okay. Fast read and write performance. Read and write. Read and write means you can store and retrieve. Okay. You can edit and all these things. ACID compliance is actually ACID stand for like A stand for something, C stand for something. I can't remember this. You guys can check. I already give you the notes under the slide here, under note section. So you can check. A for atomicity, if I'm not mistaken. Okay, you guys can check. So they are working based on SQL, work based on ACID, or NoSQL. It's not related to, no or partially work with compliance with ACID. And SQL schema is very rigid and NoSQL schema is very flexible. So the language we utilize for SQL is obviously SQL, but the language we utilize for NoSQL is like JavaScript object notation, JSON or XML. If you learn about HTML, sure there is one particular topic or chapter that you will learn about XML, extensible markup language. Okay, how this extensible markup languages look like? It's look like this one. Okay, this one is like NoSQL and versus SQL, so you guys can see. So where like product price is connected to product ingredient, product price connected to buying rate, product ingredient connected to, this is the relationship, right? But there's no such a relationship. You can see, is there any relationship between price to ingredients, ingredient to rate, rate to all other related data? There's no any connections. You can see here. There's no such things. Okay, that is the difference between NoSQL and SQL. Okay, as I told you that XML, right? Let me get the pen. XML, extensible markup language. Okay. In relational database, we know that it's a structured format, but this one is an unstructured format. Okay, unstructured format, usually we will apply or using extensible markup language. So the same thing, ID1, name, surname, age, is written as this one, this format. This format is known as XML. Okay, or JSON format as well. Okay, this is difference between relational and non-relational database. Okay, you can see I already show you the 4 types of models, right? Okay, for NoSQL. For SQL, we have like OLAP, online analytical application processing, and then relational. Okay, not much. Real life application, you can see where we do apply this non-relational database for social media platform, IoT, okay, gaming industries, content delivery networks, personalized advertising. So all these are some examples only. Yeah? So you guys can go through more detail. Okay, again, I give you one review question here so that you guys, to test your understanding about, topic 1.3. Make sure try. Okay. Summary. Non-relational database offers flexible data model that go beyond the traditional tabular structure, which is relational database. Okay, they address the limitations of relational. Even though relational database is good enough, but they do have some limitations that can be solved using non-relational database. For example, the scalability, handling diverse of data. Okay, different types of non-relational database, like we have 4 types: document, key value, column, and graph. Okay, the choice between the relational and non-relational database depends on the specific requirement of the application, including the data structure. Okay, whether the data is a structured data, unstructured data, or semi-structured data, it depends on. So whether you want to choose non-relational or relational, it's up to you based on the scenario or the situation that you are facing. Okay, so that's all for chapter 1. Okay, class, before I end up, I want to tell you that I will share a case-based study in assessment section in author. So it's like a simple multiple choice questions, I think around 5 questions only. So I want you to do the question and submit the answers. Okay, there is a time frame as well. I guess I gave like 1 day time, so you guys got time till tomorrow 5 p.m. So go through the video and do answer the case-based study multiple choice question. Thank you, class.